Hi everyone. I just want to go over some of the matrix notation that we did last week so that you have got it on record and you can then use it for your revision. Okay, I'm just going to alter my pen a little bit, I think. All right. As we have spoken about previously, we have a matrix, and if that matrix is and we will call that matrix A. Okay, now in this case we have got 2 rows, okay, 1 row, 2 rows, and we have got 3 columns, 1, 2, 3. Okay, and so the order of that matrix is a 2 by 3 matrix. Now, in mathematical speak, all right, that matrix A, when we talk about any matrix, the order is referred to as an M times N matrix. Okay, so I know that it should be row times column, but it isn't. It is M times N. Okay, now if we continue on with our formal maths type talk, when we refer to a matrix A, it is noted as being A, I, J. And that is where I can equal 1, 2, 3, up until M, which is, as we know, the number of rows, and J can equal 1, 2, 3, 4, etc. up to N, where N equals the number of columns. Now I've put this on here so that you can go over it carefully. When we were in the classroom, I drew a matrix A, and we had that in our first row, in our first column, we had A11. In our first row and our second column, we had A12. First row, third column, A13. First row, fourth column, A14, until we can go A1J, because we have got J columns. Okay, if we are going to have A here, we are in the second row and we are in the first column. A here, we're in the third row, we're in the first column. A here, we're in the fourth row, we're in the first column. And we can go on until we are A here and we are in the ith row and the first column. Okay, across here we are in, sorry, I'll just get rid of that just makes it confusing. We are in the I row and we are in the second column. We are in the I row and we are in the third column. And this goes on until we are in the I row still and the J column. And this is simply a way of identifying where we are within our matrix. So hopefully that makes sense to you. It really is simply a mapping tool. Okay, very useful terminology. Very quick. We also need to understand that two matrices are equal only if every single element in them is the same. Okay, so they have to be of the same order. And each element, whoops, that's incorrect. So in this case, what we would have is if we've got a matrix like that, obviously it is equal to a matrix like that. Okay, if we have got a matrix that is equal only when x equals A, y equals B, w equals C, and z equals D. Okay, so that's just something to keep in mind. Okay, thank you. That concludes that session.